Welcome to the Transport Leaders Podcast, where two middle-aged white blokes discuss the breakthrough ideas and bold solutions transforming the future of transport around the world. Join a global community of transport leaders, professionals, academics, and advocates as we unpack transport's toughest challenges and spotlight the strategies driving real change. From system reform levers and political realities to sustainability and technological disruption, experienced transport professionals, Graham McCabe and Russell King, and their guests offer expert perspectives as we discuss ways to transform our transport systems.
G'day, I'm Graham McCabe. I'm founder of Step Advisory, a traffic and transport planning and engineering firm. And I've got close to 30 years experience in working in Australia and Australasia.
And hello, I'm Russell King. I'm a transport strategist and the founder of the Transport Leader blog and newsletter. And I've worked on the policy side of transport for around 20 years.
Okay, Russell, what are we going to talk about today?
Today, Graham, we are going to talk about long distance freight and road freight versus rail freight and the future in a world of autonomous freight trucks.
That should be an interesting piece. I think we'll have a nice debate about whether we think autonomous trucks are how they're going to work in the Australian context.
Yeah, I think it'll look beyond Australia as well. I think there'll be a lot of discussions about how these things are going to work everywhere, to be honest. I don't think the context for Australia is unique by any stretch of the imagination when you look at the trends and the underlying challenges we see in many jurisdictions. I think we'll touch on America as well, because they have a very different governance model, and I think that'll be really interesting to debate what will happen there.
They do. They also have a much larger freight rail network than we do.
They do. And that's why I think it's very interesting. A, they have a large freight rail network, but B, also it's owned and operated by the freight rail operators, which is true in most other jurisdictions.
Yes. Yeah. Fair. All right. Well, where do you want to start?
Let's start with the freight strategies that most jurisdictions around the world have. So their top line strategy is more freight by rail and less by road,
depending on the location and the circumstances.
Yeah, but I think it's
and the type of freight.
Yeah, but I think it's true to say that that's in the most places that's the standard default policy.
Yeah, well, yeah. So things that can be containerized or bulk commodities, they're the things that you can move easily by rail. So we don't really have the situation where you have individual items being loaded into a wagon in a siding anymore.
No,
it does still exist. Europeans, yes, I acknowledge that you exist.
You suggested Europeans might feel neglected in the modern multipolar world where it's India, China, the United States, and the Europeans are forgotten. Is that what you're suggesting?
Well, yeah, no, well, it's, the old fashioned, wagons with the big double doors that open and individual pallets are loaded into them. Inefficient to say the least. Whereas modern logistics, if you're containerizing things, you fill up the container and then you move the container.
Yeah. So why
rather than putting things on a truck, taking it to a rail siding, then loading it into a rail car.
Yeah. So the reason that it's then more efficient to use a truck in those circumstances is that intermodal change. Is that fair?
It's to do, it's the cost. So you can drive a forklift in and out of a container. To load a rail car using a forklift is much more complex. And then you have to have things taken to the railhead. They need to be stored, then they need to be loaded. Whereas if you have a factory or warehousing and distribution and you load everything into your container, and then the container gets picked up and taken. So it's only where you start getting, it's like shipping. The containerization changed the sea freight industry. And it's actually what enabled us to have a global shipping industry now. It's the invention of the 20-foot container, because it makes things so much more efficient. So then if you're moving something by container, then you get to a point where you start introducing inefficiencies if you change modes. So a freight container coming from a port to a distribution center, if the distribution center is close to the port, you don't put it on rail, obviously. And then you get government intervention to have rail intermodal terminals so that you don't have lots and lots of trucks running around the roads with full and empty containers. So you put everything on a train, which is still on still rail.
Yeah. So why would governments interfere?
Because of congestion. So a semi-trailer can carry two 20-foot containers, so a tractor trailer, depending on where you are in the world. So you think of a ship that has thousands of containers. If you move them by road, and it doesn't matter if they're being driven by a person or by an autonomous truck, you're taking up road space. And we've talked about, road space and the valuation and calculation of that on other podcasts. And we don't have enough. You don't have enough land for all that.
So why don't governments just simply charge the heavy freight industry so to stop the congestion taking place? Why don't they have congestion charges on heavy road use, heavy truck use on roads?
Well, so they do in a way. So there's differential fees for trucks, and then ports will have differential fees based on when trucks are going there. They'll have curfews that you can't enter at a certain time. But the other factor is the end user's willingness to pay. If governments charge road user fees for freight, well, freight's what actually keeps economies going. Moves food for people, moves fuel for people. The trucking industry would, fairly rightly go, well, why are you taxing us when you're not taxing cars, all those single occupant cars?
Yeah.
And I'll throw it back to you because that's a political discussion.
Yeah. It's prices would go up potentially in the shops, right? Or at least that would be the claim.
And you could do things like we do at the moment, which is foods and fuels can be subsidized in a different way to your latest piece of technological crap that you don't really need.
Yes. So in effect, though, it's politically challenging for most places to charge road user charging for trucks. I'll debate whether it would give you a better social and community outcome. But so and that's one of the things that's driving the economics here is that the roads are effectively much cheaper for freight to be moved on roads than it is for freight to be moved on rail. So in the case of rail, they pay some sort of access charge to use the rail networks typically.
In the case of privately operated freight railways. And there's another form of transport, which a lot of transport engineers don't really learn or talk about that much. And that's pipelines and conveyor belts.
Oh, go on.
Well, the two things that, they are exactly what they sound like. But if you're doing bulk commodities fuel you can do over, liquids you can do over very large distances. But intermediate distances, particularly in the mining industries, a lot of movement's done by conveyor belts.
Yeah. And you can see quite a lot of that in, say, the Hunter region of New South Wales, where there's lots of coal mines and direct connections to the port of Newcastle for shipping to China, typically.
Well, that's a mostly rail connection to the port, but within the port, yes, massive conveyor belts.
Yeah. And then I think there's also a debate about the aviation fuel pipeline going to the new Western Sydney airport as well, because of the number of trucks that will be required to provide the fuel and the safety implications and those sorts of things. But it's been discussed for a long time, hasn't it? And hasn't been realised yet.
Yeah, well, so again, having worked on the planning and the AIS, a little bit circumspect in what I say, but the initial operations will be that the avgas will be transported by B-double with longer term planning for a pipeline. But we've been through this before. In the 1990s, there was government decisions to stop subsidising fuel travel by rail. So previously Canberra, which is Australia's capital, but also 250 kilometres southwest of Sydney, used to have a fuel train that went there once a week, and that got replaced by 20 B-doubles a day. I believe is the number because the government stopped subsidising it. So all the costs were transferred onto a different part of the government, which was the maintenance of the road network.
Yes. So because our roads are heavily subsidized in one way or another, it makes road freight, it distorts the market for long distance freight, and we're in favor of road freight over rail freight. And that's true around the world as well. Almost every jurisdiction, and this includes the federal government in Australia, but it also includes, most of the countries in the European Union, if not all of them, you know, have all had increased the mode share of freight moved by rail over freight moved by road. And they've all pretty much failed.
No, they don't fail. No, they're actually quite successful.
Well, their mode share, they've got targets for mode share going up for rail freight, and their mode share is going down.
Yeah, so they are long terms, but they're eating into the growth of road freight transport.
Yeah.
So the total freight task is going up.
Yes.
They may not be getting the ultimate mode share target, but they are reducing the growth in road freight.
Yes. But that's not what they're trying to achieve in their strategy.
Well,
It's kind of like
it goes back to the same old thing. When one part of the transport network is being subsidized and the other one's not,
that's my point, right?
Wins.
This is not, so the question then becomes, right, that the strategy is not being met, right? They're not hitting their key core performance indicator. I appreciate they're partially meeting a target in the sense of it's reducing compared to the growth there would be on the road freight, but they're not meeting their targets. So part of that's the road subsidy, but there's other constraints as well in this, right?
Yes.
Right. So you've got challenges in terms of the constraints of the infrastructure. And in particular, they have things like conflicts with passenger services. So most of the rail networks also carry passengers, and there's only a certain number of trains you can often get through the infrastructure. And in a lot of places, they struggle with, conflicts between what freight wants and what the passenger services need.
Within the Australian context, with the exception of small parts of Sydney and the lines between Newcastle and Wollongong, freight wins out. And good chunks of Sydney, so southern Sydney and to the port, have dedicated freight lines. Sydney to the west and Sydney towards Newcastle, Sydney to Newcastle, there are small sections of freight track within Sydney. But once you get outside of Sydney, up to Newcastle, it's shared corridor. And Sydney to Wollongong and Sydney to the Blue Mountains is shared corridor. Once you get, and it's similar in, Brisbane and Melbourne are a bit different because the freight rail generally, with some exceptions, like the interstate freight rail, operates on a different gauge of network. So the freight rail is much more segregated than within Sydney.
Yes.
And outside of those areas, freight rail wins out over passenger rail.
Yeah. Now you touched on the gauge challenge, but this actually is an example of some of the governance challenges we have in freight rail as well. In that, in many places, freight rail crosses multiple government jurisdictions.
Yeah, and we have our freight network the interstate freight network is standard gauge, so 1435 millimeters, 12-foot, what is it, 8.5 or something. I don't care about imperial units.
Yeah, but gauge is an extreme example, but their systems are often different from jurisdiction to jurisdiction, such as the safety systems they're using and those sorts of condition monitoring systems and other things. And different rules and regulations that you have to follow within each of those jurisdictions.
We are in the process of the country is in the process of standardizing them, so that there's a standard set of what are called working requirements for the routes.
But at the moment, it means that it makes freight more expensive because you've got to have additional hardware on the trains. You've got to have additional procedures that vary depending on the jurisdiction you're in, etc. Right? So it's all adding up operating costs and stuff. So you've got that added problem as well.
Yeah. And you end up with drivers who understand the different systems. So you end up with more than two drivers across a long distance route.
Yeah. And then you've got the challenge around the quality of the infrastructure as well. So increasingly reliability is a challenge as rail networks are more exposed to changes in climate, increased flooding risk, those sorts of things.
Yeah.
Right. And there isn't the money to invest necessarily in resilience. So you've got that challenge. So given all of these things, so congestion was one of the reasons we gave for why the strategy was to grow freight rail over road freight. But it's not the only one, is it?
Well, there's pollution, so that's mostly air pollution. So trucks have different emissions requirements to passenger vehicles. So a lot of the particulates in urban environments come from diesel trucks, but in theory that gets resolved with electrification. Other one's actually age. So a lot of the trucking industry is actually aging out. So
We're talking people or trucks themselves. Yes.
So no, the number of young people who want to take up trucking, given it's a very, very low margin activity. Most freight operators, a 2.5%, 3.5% margin after all the costs and salaries, etc. Yeah. So, and a lot of freight companies are struggling, many going under. So you don't have the desire there. And when automation, rail systems are much easier to automate than road systems. So, if there's a case for automation of freight, then it's actually in the rail space, I think.
Yeah. So let's talk about that then. So for freight, why is freight rail not already automated? Because it's not as though we don't have automated rail systems, right? We do have automated rail systems, but
we do. We have automated freight rail systems. So a lot of the iron ore that's moved in Northwest Australia is actually controlled from a control room in Perth.
Yeah.
The trains are automated.
Yeah. So this is where this is the freight effectively it's dedicated line or close to it. Where it's moving huge amounts of commodities from mines into the ports, right?
Yeah. But they go through public road crossings. So they are actually interacting and they're also not fenced at all.
Yeah. Which then touches on talk about the safety issues. Safety is another consideration here as well, isn't it? So,
well, though a freight train will take a long freight train, it will take a kilometre to stop. So it doesn't matter in a way, like, of course, it matters. A
reaction time is not the big thing.
Yes, a reaction time of a driver versus reaction time of somebody sitting in a control room 2,000 kilometres away.
It's neither here nor
there. No. The train's not coming to a stop.
Yeah,
but within the sight distance of the vehicle.
Yeah. So although there are challenges with level crossings and rail freight, I think rail is still a lot safer than road freight currently.
Yes.
Right. And it's another one of the drivers for saying put more stuff on rail. So even though it's not perfectly safe, and let's be frank, it's no perfect system, but even with the problems at level crossings, one of the other drivers for moving freight from roads to rail is safety, because road trucks are much less safe than the rail, right? So that's another reason for the strategic drivers.
Yeah. So and freight is measured on per ton kilometre. So it's how many crashes are you having per million ton kilometres or billion ton kilometres that are being travelled? So the freight task is in hundreds of billions of ton kilometres per year in Australia.
And the answer on rail is a lot less than the answer on road trucks, right?
Well, it's the number of zeros after the decimal point as a crash rate is quite significant.
Yes.
Yeah.
All right. So to sum up then, all right, with some exceptions, rail freight has been going backwards in terms of mode share generally, right? And there's some inbuilt reasons for that, despite the strategy that we want. And so although you rightly point out that we have still reduced the increase that we would see in road mode share, why do you think they haven't reached the targets?
So the way, again, it comes down to the different types of operation and land use. So, you can still see this a lot in the US and Canada is small sidings, small railway lines where you may have, a few carriages dropped off and an engine that comes along every few days and picks up the carriages. So that old style loading that I was talking about, run by private railways, and they often operate at low speeds. So we used to have that in Australia. We used to have lots of private sidings and engines that would run around and pick up all these carriages and combine them into trains, subsidised by government. So, externalising the costs away from government into, well, those costs can go into the trucking industry. Changes in manufacturing processes. So, just in time manufacturing, fast shipping of things, increasing use of long distance travel of fruits and vegetables. So, now a lot of stuff's more, snap frozen. That's how you get you can have your pink lady apples all year now because they do a massive harvest and then they just snap freeze them and stick them in cold storage. Previously, you had a time limit on how fast you could get stuff to market and the rail system couldn't keep up with it. So the rail system was very, and still is very good at long distance and things that are in a hurry, or things that have very large volume. So bulk commodities, things that are time sensitive, and it's still that way, and that's how it is everywhere in the world. If it's bulky or it doesn't rely on time.
It's not quite true in everywhere in the world, right? Because America's got a much higher freight rail mode share.
Not so much for time sensitive things.
Yeah, but in terms of its overall freight, I mean, it's not just right. You got to look at the whole of the freight task, right? I appreciate there's going to be commodities where it's not going to work, but for America has a much higher freight rail mode share as a total proportion of its freight movements than anywhere else in the world, pretty much. Not, I don't know about everywhere in the world, but certainly more than Europe, Australia, most of Asia.
Yeah. So the freight railways have always been private.
Yeah.
In America, a lot of them were concessions. Here's some land, go build a railway line, and you can build some company towns along the way.
Yeah.
So, there's I suppose a different market incentive there. So there's a competition, which is how you end up with the situation now where you have these 3 kilometre long trains that just block the entireties of a town because of their scheduling requirements and the fact that the town's got a whole heap of level crossings in it. And the freight railway company doesn't care about the town, whose roads they're blocking.
Yeah. I mean, that fundamentally answers the point about why do they have, a much higher mode share? One is they own the rail network, right, and have clear priority on the rail network, so they're not subject to.
They have monopoly on the rail.
Well, yes, I mean not quite in the sense of they often share it with an Amtrak or something, but they own it, right? So they decide on who the priority is, and they agree when Amtrak can use it and when it can't. And if their freight is running late, Amtrak gets bumped, for example.
Yeah, but they also don't allow competitive railway.
In that sense, yes. Yeah, there's that. But, but that's just an integrated model, right? That's their integrated, approach. But it's very efficient for freight rail, right? It's not so great for passenger services, right? Amtrak has all sorts of challenges keeping up its sort of reliability in its service offering because of that. But as you say, and it doesn't worry about political challenges of closing half a town down for 3 kilometers, right? On the crossings, right? That's the quid pro quo, but it's but that's because that's then a very efficient way of moving things. It has a very, much higher mode share than.
Yeah. So they can assemble long trains. They can run them for long durations across large distances, and they can run them frequently.
Yeah.
But they're trying to run. So it'd be interesting to see how much they cannibalize their own market by the fact that they're running exceedingly long trains in order to run fewer trains. That's whether that then has a negative impact because they lose that, I suppose, that value of having the monopoly. They become a monopsony of, if you want to move something, well, you've only got one seller of the service, in the railway. So you go, well, I'll go to the road freight industry because then there's actual competition.
Yes. Now, which then brings us on to the road freight versus rail freight discussion. Okay. So one of the things that we haven't really talked about yet, which has made road freight more efficient and competitive against rail freight, is that a lot of jurisdictions have allowed ever bigger trucks onto their roads.
Yeah, look, when you're going from a 40-ton semi-trailer to a 56-ton B double, are you really, you're over a long distance, so a big chunk of fuel usage of moving a truck is
Yeah.
just moving the truck.
Yeah.
So, and then you get, incremental increases. So there is a significant cost saving for the operator between 40 and, 48 tons and 56 tons.
Yeah.
But that was great for bulk operators. But a lot of freight is actually about cubes. How many cubic feet, how many cubic meters of stuff. So that's where long trucks really work, is that you can get in an A double configuration, which is about 36 meters long. That's 100 feet roughly. Again, not a big fan of imperial units.
Just for the American listeners, they are not American units, they are imperial units. Even if the Brits have stopped using them, it is still the imperial system.
Yeah, so if bulk is your issue, being able to have two 40-foot containers on your truck is a significant improvement.
Yes.
Because your mass may not be going up to the 56 tons.
Yeah.
But your volume is increasing massively in what you can carry.
Yeah. My point is that we have not helped our strategies around growing freight rail by making road freight more competitive.
Yeah.
Okay?
One of my first jobs first task when I was an undergraduate in the Roads and Traffic Authority was assisting in working out what the increased maintenance costs would be of increasing the general mass limit for semi-trailers.
Yes.
So
okay, let's touch on electrification because I think it's an important factor here, right? As you said earlier, our expectation is that there's a pathway through for trucks. There are some challenges with electrification that trucks are still having to work through. They drain the batteries because they're very heavy things.
Again, because you're carrying the mass of the battery around with you all the time, the differential of having freight or not having freight is actually quite small.
Yeah.
Yeah. So electric trucks are super efficient.
Yeah. But then they have to have the recharge challenge, or at least the swapping out of the batteries at the moment.
Yeah.
We're talking about, trucks going more than, say, 1,000 kilometers plus, right? My understanding is that some of them have, the distances are prohibitive from running all the time. You need charging time.
Yeah. So, okay, we'll get into autonomy, but so I do quite a bit of work in electric trucking. So there's requirements around mandatory brakes, and then there's human frailty.
Yeah.
Drivers need brakes because they need to get coffee, go to the loo.
Yeah.
They also have mandatory rest breaks. So the limitation isn't on the trucks or the charging. Those things are actually easily solvable. So you can it's just capital cost and infrastructure. The things that are holding electric trucking back and preconceptions.
Yeah. So this is true if there's a human stopping anyway. So
Yes,
before we get on,
what I'm saying is
we'll get on to
there's human
autonomy.
factors, yeah.
Yeah, we'll get on to autonomy in a bit. But then the next thing, right? So that's the decarbonization pathway for trucks. What does the decarbonization pathway look for, like for freight rail?
For freight rail.
Yeah.
Well,
Because they're all diesel engines at the moment, aren't they, predominantly?
Yeah. So it depends on where you are in the world. So Europe, Japan, China, India, it's electric primarily. So, and then then you've got different types of diesel. So you've got just straight diesel engines. Then you've got diesel electric, which are the powerful locomotives. So they're diesel generators, and all the traction actually comes through an electric motor.
Yeah.
So, I mean, you can go down the old fashioned path of having catenary and power lines and pantographs and electrify your rail system, which is what India is doing right now. The remaining bits in India that are electrified, they're very rapidly electrifying. You can go battery, particularly if you're going downhill on a gradient.
Yep.
And you're carrying commodities. So while it hasn't quite turned out, there was an idea from Fortescue Metal in the northwest of Australia called the gravity train, which was in theory a train that was going to charge up the batteries in the locomotives on the way down the hill when it was full of iron ore through braking, and that would give it all the energy to get back up the hill when it was empty. Hasn't quite turned out like that. Laws of physics got in the way a little bit with energy losses and etc. You can have, so you can do catenary, you can do third rail, but freight rail, it's going to be sustainable fuels if you're not properly electrified.
Yeah, and there's a lot.
Even so, the amount of CO2 that you're generating per ton kilometre of freight that you'll move is very low. So it's one of those ones where you go, well, let's do passenger cars, let's do open freight, let's do electricity generation. There's lots and lots of things that you can do first to reduce the amount of CO2.
The key thing for me here is if you're looking at the road freight versus rail freight discussion on carbon emissions, the advantage that rail freight has at the moment, because road trucks are all diesel, or the vast majority, is going to disappear.
No, they're all diesel.
Yeah, it's going to disappear is my point. Okay, we're talking about a sort of, we're not talking the next 3 years, but we're not talking about the next 300 for sure. But it's, it'll be somewhere in between, probably the next couple of decades, I'm guessing. Right. So, so let's then.
Oh, and you can run battery carriages as well.
Yeah.
On trains.
So let's talk about then the impact of autonomy, right, on road freight. So you touched on it earlier, human frailty. These humans, they seem to be quite, inadequate in many ways. They need to have rest breaks for going to the toilet. They need to have fatigue breaks. They don't seem to be able to drive for 24 hours. They seem to be completely and utterly, out of date and in the past. Surely autonomy is going to fix all of these problems, right?
But there's other things that they can do, and one of them's change a tyre. Trucks often have tyres explode because of the pressures that they're under. And when a tyre explodes, you need to pull over and replace it.
Yeah.
So unless you have solid tyres and your maintenance regime is impeccable, autonomous trucks running around the countryside will have failures. Now, I'm not saying they're not going to save a lot of money in the interim. And then they also have another issue, which is theft.
Yep.
So normally having a truck driver to keep an eye on the cargo is a useful thing. I mean, they're never going to stop determined thieves or bandits.
Yeah. But it significantly raises the bar. You don't have to deal with a human being.
Well, yes. Yeah. It raises your risk profile of should something go wrong when you're robbing a truck that has a human. Whereas, and I don't know if you've ever seen videos of what was happening outside the port of Los Angeles with the way that the freight trains were being raided because there's no security to keep an eye on them. So very targeted people knowing which containers to break into and cleaning them out.
Interesting.
Yeah.
So do you believe that this will be sufficient to stop autonomous trucks?
No. So
what's the cost?
Like our discussion about autonomous buses, so the role of the driver can change in the interim so that you can actually open up trucks that have a lot of advanced driving features and electrification, open the industry up to a wider swathe of the population. And we're finding this with electric trucking. So, because electric trucks are generally brand new, they have all the current most adaptive features. They're not stinky, they're not noisy, they're not dirty.
They're more pleasant to be in. Yeah.
They're more pleasant to be in. And so the range of people who are interested in driving them is much wider than the range of people who are interested in driving diesel trucks.
Yeah. So, but
And you have also have less fatigue.
yeah, but do you think that would be a long-term solution, or do you actually think that that will be a kind of interim until because current technology on autonomy it's not very resilient in lots of ways, and it's not very good in terms of large trucks at the moment, proven in urban areas, right? So you kind of got that edge challenge. Do you think though that in the next few years, actually, you'll get to a point where you're not going to need that human presence in the vast majority of cases? Because the big saving for automation is removing the human presence, right? That's where big savings will be made, both in terms of the wage cost, but also in terms of the truck being able to move for much longer periods than it does today.
Yeah. So you might end up in a similar situation to automated ports or automated railways, where you have fewer people who are working from control rooms who are doing regular shifts.
Yeah.
So they're not fatigued. And you take away the fatigue element. And you may have drivers who are present in the cab for the first and last mile. So, when the truck's not on a motorway.
Yeah, and I think that's probably where I think we'll get to quite quickly, and I think it'll take a lot longer to get beyond that. Now, the remote monitoring makes sense as well. We're already seeing that with robo taxis. I'm sure the same will be true on autonomous trucks. I mean, on the trials, that's what they're doing, right? And so, one person in a remote monitoring center is looking after multiple trucks. The ratio, I'm sure, will get bigger as over time as the autonomy technology improves. The challenge, I guess, then is we're going to see, that will significantly reduce the costs of autonomous trucks. So McKinsey's got an estimate of for trucking above 1,500 miles, I think a 42% reduction in the cost of a truck. Now, even if it's half that, right, that's a lot of saving in a very low margin business.
Yeah. So electric trucking alone is probably going to get you at least half of that. So then you've got the tech. It'd be interesting to see McKinsey's numbers, but there's probably things where they're relying on government investment and improved road infrastructure and improved communication systems.
Yeah. So one of the things here is around, you're right. It does assume that, because one of the things your trucks need is connectivity, right? For monitoring the truck, right? And in many regional, and rural areas, connectivity is not necessarily fantastic, right? Now, do I think those things can be relatively solved these days when I look at the extension, for example, of satellite connections that's, coming down in cost and increasing in availability, right?
A lot of trucks are already satellite connected.
Yeah, right.
Particularly anything of value. The truck's satellite connected, and potentially the container as well.
Yeah, but not in terms, not for remote level management, are they? Do they have the bandwidth for that, or are they doing it for things like GPS tracking? Is that what you're thinking?
No, well, there's
Beyond that.
communications. Yeah, to not name a specific brand, but there is a brand that has thousands of high-speed internet satellites flying around in low Earth orbit.
Yes,
which doesn't charge a huge amount per month.
No.
And they've got competition. Admittedly, some satellite connections don't work that well when there's heavy cloud cover.
Yeah.
So then you still need roadside infrastructure and coverage, and you're going to need sixth generation connectivity. So five's not going to cut it at a large scale.
Okay. So there's a kind of dependent on the telcos upping the infrastructure capacity and capability, and then there's a kind of what's the business model justification for that then?
Yeah, and after they do the urban areas, they always do the major highways because
for me, it's kind of like, is this going to stop autonomy in its tracks in the longer term? no, it'll probably just slow the rollout rather than stop it.
Or it'll be like robot taxis, restricted to key corridors and urban areas.
Yeah. Yeah. I mean, they're already restricted to key corridors where they're being trialed anyway, because they're typically trying to pick places where the weather is not highly variable and it's dry, warm, not raining and snowing regularly, because our autonomous technology is not capable of dealing with those conditions yet.
Well, yeah, because the algorithms rely on training data.
Yeah, and we don't have the training data on rainy roads and snowy roads, right? You can see them getting there eventually, but yes, at the moment they're not there.
And going, from personal experience, having owned a very highly connected car, I've watched its evolution from not just myself, but the thousands of other people who have this brand. As it's got more and more training data, it's gotten better and better at the windy roads in my area. Yeah.
Real-time improvements you're watching. The question then, okay, so we've got autonomous trucks. The price is going to come down, or the cost of running these trucks is going to be very significantly lower, right? Doesn't this just continue to undermine freight rail? I mean, I appreciate in your kind of iron ore to example, it's irrelevant, right? But isn't it just going to lose more mode share? Is that where we're going to go?
Well, okay, you do have, okay, so the inherent efficiency of steel wheel on steel rail, and the ability to pull a large number of carriages with a fairly small engine or motor of a train for things that aren't time sensitive and are going over long distances.
I'm not saying there won't be any freight rail, but its mode share is going to drop, isn't it? I mean, it's probably going to drop significantly.
But that's where, we're talking about how, they're not achieving their targets, but as being increasing. So the inland rail line between Melbourne and Brisbane.
Yeah.
You think about that. So that's, 30 billion plus railway, dedicated freight rail line. Never have any passenger services on it. Might have tourist trains occasionally.
Yeah.
After they started building that, the communities along the route went, we're not actually getting anything from this.
Yeah.
Because they're not building intermodal terminals. They're not building freight hubs.
Yeah.
Because the model of freight that they're talking about is a whole heap of containers get loaded off at the port of Melbourne and they go by train to Brisbane.
Yeah.
Because that's a lower cost than taking a ship around to Brisbane. So yeah, there'll be there's the intermodal terminal that's being built at Beveridge on the northern edge of Melbourne. The one at Albury will get upgraded. They're building a new one at Parkes for the east-west connection. You might have a new siding or two up at Dubbo, and a few other places. But the people who are building this railway line, they don't see demand for lots of little trains going into little sidings. This is the freight rail version of high-speed rail. How can we get freight rail from Melbourne to Brisbane without going through Sydney?
Yes. But I agree, will it work for those types of products? Yes. I don't know enough about the economics on inland rail to have a look at.
They're about as bad as the investment in the Hume Highway between Sydney and Melbourne, turning that into a motorway.
So not a strong business.
So good chunks of that had a cost benefit ratio of about 0.2.
That's pretty bad. Nation building project, don't you? But my point is, I think what we're looking at here is freight rail will lose even more market share, mode share. So the question then is, what's the consequences of that? Right? So the obvious problem is going to be more congestion, isn't it? I mean, we've talked about safety, and autonomous trucks will probably be, we'll go on to safety, but we've talked about carbon emissions, and these trucks are going to be electric. What are they going to do to congestion? So suddenly we've got a whole bunch of more trucks on the road than we would have otherwise. Are we going to see much more congestion? Or are we just basically going to induce a whole load of demand and create lots of congestion?
Well, that's what we've done with the frequent deliveries. Your online shopping.
Yeah,
apps.
but this is We'll do last mile next week.
No. But they've increased the bulk demand for freight.
Yes.
So the fact
So
that you can buy something really cheap and get it delivered really quickly has increased demand from the ports to the distribution centers, from the distribution centers to the local hubs for that last mile delivery.
Yeah. But so it's had an upstream effect on freight demand, long distance freight demand.
Yes. So if you drive down the cost of freight by taking out the drivers and taking out the diesel, then the cost of those products will go down. Because even though a lot of people think they're getting free delivery, not.
I appreciate that. I appreciate those costs will then go down, but what's the impact on congestion?
Well, basic economics, costs go down, the demand curve goes up.
Yeah. Now, the question for me then is, does this going to just simply increase congestion? But there's an added complication for me with automation, which is trucks don't drive at night at the moment because of the human drivers typically.
They don't drive at night because of the noise.
Well, there's a noise factor as well, but that's not true in the middle of the freeway.
No, so the human factor isn't just the driving, it's also the intermediate steps. So if you go from automated port, putting a container on an automated truck, which goes to an automated distribution center, be split up and then parcelized to go out into a automated last mile vehicle, and they're all electric and quiet. Yes, you can do 24 hours a day. But in the process, you've created no one with any purchasing power because there's no jobs left unless we go to
that's not quite true, is it? And I'm not going to go on that. That's the same argument for not building bridges, right? We put all these ferrymen out of work. But
no, we'll have lots of people who are good at fixing machines.
Well, yes, and podcasts will be created by AI systems as well. So podcasters will be out of the job.
That already exists.
It does, but they're not quite good enough yet that humans listen to them. I think it's en masse, but they might get there.
Speaking of which, buy us a coffee or a train ticket so we can actually make this better and not get replaced by automation.
Yes, but for me that means that potentially, if you get the right pricing signals, you could make those trucks go at night rather than during the day when the roads are quiet, and so you could offset the congestion problem. Because if you've got a significant reduction in price, theoretically at the same time you could say, for autonomous trucks, we're going to put road pricing on them, road user charging, and it'll be a lot more during the day than it will at night because it's more congested, right? Yeah. And then you create an economic incentive to move your truck to moving at night. And as you said, the noise problem goes away relatively compared to diesel truck. Okay. So do you end up with not a congestion problem as a result? Now, I appreciate there'll be some localized examples where that's not the case, but then it's that's a case of the question of getting the road price right to create the right incentives. If you combine it with a road price, wouldn't we now utilize the road assets we've got more effectively because now we'd be moving more freight at night when the roads are quiet?
So there would be an interesting interplay with the electricity market of when it's cheap to charge those systems. So if they're all electric, it's still cheaper than diesel, but you don't want to be charging those systems at 5 to 7 p.m. at night, for example. That's when they should be on the road. Yeah. So your cost structure of the road pricing needs to incentivize that they're actually not drawing from the grid at that time.
Yeah, there's a whole bunch of economic modeling that needs to take place for your pricing, right?
Yeah, but I guarantee you that the two groups ain't talking to each other.
Well, there's no road pricing group at the moment at all. So I can guarantee they're not talking to each other because there isn't a road pricing group, right? But I know what you mean, right? And there is. And do I think we'll get the road pricing right first time? No. One of the things I think about the road pricing is you don't want to end up like you do with our congestion zone pricing, where we go, this is the price, and it kind of like it stays that price apart from going up with whatever the inflation rate is. The price should be more dynamic than that. I think that's one of the things that we need to look at when we do more ubiquitous road user charging. But the question for me becomes then, well, if our strategy was moving to freight rail, right? So the argument on the environment has been closed at least, okay, because as trucks move to electric, right? The safety argument then, the congestion argument might go away for you to road pricing. What about the safety question? I mean, the thing I would say is At the moment, human-driven trucks are more dangerous than trains. And my guess is that even with autonomous trucks, they'll be less safe than trains, possibly, right?
Yeah, yeah,
They'll improve,
inevitably they will be.
right? But the gap will be quite significantly closed compared to today, would be my prediction, right? So the argument for freight rail in terms of having priority in our strategies, for me, just the case for doing that is completely undermined. I'm not saying I give up on freight rail and just say, put everything on a road. That's not where I'm coming from, and I'm someone who's always been a historic, freight rail should be our strategic priority. But I'm wondering whether in a world of autonomous road freight, we should accept the fact that that gap between why you want to go to freight rail and why you want to over road freight has narrowed significantly, possibly to the point where if you combine it with road pricing, you can let sort of the economics work and just say, we won't favor any particular mode. What we'll do is we'll price the road appropriately, we'll price the rail appropriately, and then people will decide which is the right, depending on the commodity that they've got. So the inherent advantages of freight rail in some markets will work really well, and the inherent advantages of road freight in other markets will work really well.
So there's still the congestion issue. So, as you induce more demand, the activity increases to fill the available capacity. You look at the mega cities of the world; they're busy their transport systems are busy 24 hours a day.
Are they? I mean,
Uh,
I say this, having lived in, and visited many of those cities. They're quiet at night relatively.
but the industrial activity, so industry, so your CBDs, your residential areas are quiet, but you go out to where the factories are. Like, the person making the factory making your biscuits to dip in your cup of tea is probably running 18 to 20 hours a day, if not 24.
Yeah, no, I appreciate they are, but they're not
Yeah.
generating huge amounts of congestion at those times, right?
No, they're not. But if your system starts falling down or gets too spread out, then you have that constant, transport demand. Yes, it's faster to drive across Los Angeles and Orange counties at 3 a.m. than it is at 9 a.m., but it still ain't free flow conditions. When
My
I was
point,
working in the Philippines, they would get me to go to the airport for a 7 a.m. flight. I get picked up at 4:30 in the morning.
yeah, but my question really is, right? Okay, there may not be free flowing conditions, but it's not what we call congested, right? So from and it won't be free to travel at night, on a road pricing system, on a road user charging system. Okay. But they'll just prioritize traveling at night compared to traveling during the day because the economics will make sense to do it at night rather than during the day. And that,
No, I don't disagree with that. But
all I'm saying is I think we've got a lot of spare capacity on the roads in the middle of the night, right?
yeah,
But
so
then
we,
if
we,
the pricing
we
system
run
then
into the same problem. We run into the same problem of the number of vehicles that you need to move things.
yeah.
So it becomes a capital cost exercise. So, how many autonomous trucks do you need to be running around? And that's assuming that the systems that they're going to are also autonomous. Using that example, if you're going from autonomous port to autonomous DC via autonomous truck, then you can run that 24/7. And you
Yeah.
can say, okay, well, we will actually run this from 6 p.m. to 6 a.m.
Yeah. And one of the questions will be is, does the road pricing economics prevent that? Right? Because, if you try running it at, say, 6 in the morning till 10 in the morning peak, you're going to be paying big price costs. And so the economics don't stack up. And for me, so although I don't, if you left it with unpriced, completely agree with you, right? That's what you'd get. But if you're pricing it properly, then I think you could avoid that problem. And although it'll cost more because you can't now run it 24/7 and you have to shift those trucks to, say, before 6 a.m. Okay. The cost of doing that should be very small in comparison to the cost of driving during that time, during that peak time because of the road pricing system. And so you're going to be using that spare capacity that's there before 6 a.m., aren't you? So it's not, but that's all I'm saying is, there'll be exceptions. Don't get me wrong. There'll be places where, you're putting so many additional trucks in, you could create congestion at night at 3 in the morning. But I think in most places, actually, it won't be a problem to begin with. And if truck demand keeps going up, that's when you're adjusting your road pricing anyway. So then your rail freight becomes more competitive anyway, doesn't it? And so, you're
Well,
kind of
yeah,
you're kind of creating that dynamic where your road pricing is reflecting the cost of congestion. And so that's kind of constantly shifting the dynamics between the road and the rail. And so if the road reaches a point where it is creating a lot of congestion, even in the middle of the night, that shifts it to rail.
yeah, except for that capital cost aspect of purchasing the vehicles. One train can pull half a kilometre's worth of carriages. The freight rail industries. This train's replacing
Yes.
100 doubles or whatever they call. As as their numbers per engine. So obviously, somebody needs to buy all those trucks.
Yes. And it's a really important point because then this is a low margin industry. Capital cost is a really difficult thing. Okay. And they need to get those assets used over a very long period of time. They don't get return on those assets in 3 years, right?
No,
They're
no.
using
So
those assets
most
for
trucks go
20 plus
through.
years.
So each current truck from new will have around 4 to 5 lives. So it might start out with a prime logistics company who I know your big, very large companies. They'll use it for 5 to 8 years.
Yep.
And then it'll get sold to the subcontractor.
Yeah.
Yeah. And then it'll get sold down to the sole trader level.
Yeah.
And then it'll get sold to be used on a farm.
Yeah. And so you can see how I think one of the things here is if you're dynamically changing the price on the roads and the market is dynamically changing, it creates a lot less certainty for freight rail companies to invest, right? Unless they're confident that the price won't go on the road user charging won't go down. So if their expectation is that the road user charge will only go up because congestion is increasing over time, and so that in order to compensate, road user charging will continue to go up, then they can provide that certainty, which probably will work out. Because I think it's unlikely we'll be unless it's a recession, in which case all bets are off. But in which case, you could see a scenario where the congestion is significantly reduced in the circumstances of a recession, and so your price of your roads would go down.
Yes. Yeah. Well, as I said, a little bit facetiously when I was running a workshop for a transport strategy, when somebody said, we want to eliminate congestion. And I was like, do you remember the Asian financial crisis? And they went, yep. And I said, were the roads busy at the time? And they went, no. And I went, you don't have an economy, you don't have congestion.
Yes, absolutely. Yes. You have road pricing is the alternative, which often is out of the control of most jurisdictions.
I should say, you don't have demand for travel.
Yes, that's right.
When nobody has any money, there's no demand for travel.
Yes. Or you make traveling really expensive through road user charging alternative. But that's probably not productive. It's productive up to a point, but when you go beyond it, it's not, right? Anyway, I think to wrap this up, I think the conclusion we get to is, for me, is at least, and you might disagree, but my conclusion is pushing freight rail as the priority is not where I would be going from now on. What I would be going for is how do we create a proper competitive system between freight rail and road freight moving forward in a world of autonomy? And so I would be focusing on what I need to be doing is pricing the autonomous trucks. Okay. And the thing about that is, as they come out, is pay road user charging. So it will reduce the saving that trucking companies get from going to autonomy, but it shouldn't be more that it should still have significant incentives to go autonomous. But at the same time, you're getting the benefits of that road user charging and being able to manage the demand on.
I hope you enjoyed our little side diversions into the economics of autonomy. And please feel free to comment, follow us on all the various platforms. And if you're really generous, as I mentioned earlier, buy us a coffee or a train ticket and help us make this a little bit more professional rather than two guys doing it using Google Meet. And once again, thanks, Russell.
Thank you very much, Graham. And goodbye. It's great listening and talking to you as always.